Good morning. My name is Lee Lowry. I'm with the Department of Civil Engineering at Texas A&M University. And this afternoon I am going to give you assistance on learning the material on economics, which we feel is likely to appear on the Fundamentals of Engineering exam. Economics is basically moving money from some point in time to some other point in time. Long ago, people found that if they made money, it was fun to spend it, but that they could actually make some more money if they would loan it to someone else. But obviously, if you're going to loan that money to someone else, there is a risk they won't pay it back. They're getting to use it while you are not. There is also a risk of inflation, that the dollars they pay you back with, even if more than you loaned them, may turn out to buy less for you than they would have had you just gone ahead and bought something in the first place. So we use an interest rate to indicate the value of money. Now, moving money from one point in time to the other, sometimes you need to know how to move money from now to later. For instance, if you want to borrow some money now and pay it back later at a given interest rate, the question is, how much would you have to pay back later? 1 year later, 2 years later, 3 years later, or perhaps 1 month later, or 2 months later, or 3 months later, or perhaps 1 decade later, or 2 decades. So these units of the timeline will need to be specified in the problem. For the most simple problems, there'll probably be years. Sometimes these payment periods will be like a half year, or perhaps a quarter of a year. Now, I'm not going to go through the derivation of the equations. We do in most classes, of course, but in this instance, we're interested only in being able to solve problems. So I'm just going to take the equations given to us right out of the Fundamentals of Engineering reference manual. Furthermore, there's a lot of good economics that will not appear in this tape. However, the purpose again being to get you through this quiz. If the reference manual does not have the equation for some of the niftier economics problems, then they will not appear on the exam. Alright, now let's assume that we have borrowed $20,000 from the bank for a period of 1 year. They are requiring us to pay an interest rate compounded at the end of each year of 6%. Question is, how much do we owe the bank after 1 year? Normally, a cash flow diagram is a valuable thing to draw. You'll notice here we took money out of the bank, and 1 year later we put money back into the bank. This would probably be from the bank's point of view. Someone took some money out. Later on they put it in. The put in error is supposed to be bigger than the took out arrow. And the equation for such use of money is that the future value is equal to the present value times 1 plus the interest rate raised to the number of compounding periods, or in this case the number of years that you wish to borrow the money. Now, a very nifty way to write this down, and which allows you to use interest tables, is to say that future is equal to, the future value of the money is equal to the present value of the money multiplied times a factor, and the factor is called f over p comma I comma n. And what it really represents is nothing more than 1 plus the interest rate per year raised to the number of years that you are going to borrow the money. So what this says is that the future value is equal to the present value of the money borrowed times a factor which can be found in some tables. These tables will depend on which column you use. There are numerous columns in each table. We want the column which will be labeled F over P. An interesting choice of column name, because you'll notice that if you want to take a present value and change it into a future value, common mathematical operations might say multiply it times the ratio of F over P. Now this is not necessarily what it is, but this is the way it looks. It says, what I'd like to do is I'd like to take a present value, then present value would cancel out present value, and I could then multiply it times a factor where F is over P. If P cancels P, I'm left with F. Now the reason they do that is because in all these columns, that allows you to determine which column to use. If you want P, if you're given P, you'd like to turn it into F, you know immediately, go to the F over P column, because P looks like it cancels P, leaving you with F, and you want F. Now there's a little more to the factor than that. Another thing that influences the value of this factor is the interest rate which was used to calculate it. Obviously, if you're at 6%, 8%, 10%, you're going to have to use a different factor. This I value is in the table at the top of the page, or at the top of the table. They'll give you things for 2%, 4%, 6%. And then along the row, they'll give you the number of years or the number of payment periods. So as an example here, I'm just going to go to the book and show you a typical table. It's called a factor table for I is equal to 6%. If someone wants to change a present value into a future value, or a future value into a present value, or a present value into an annuity, or all of these kind of things, you simply look at the top of the table heading and figure out which column you're looking for. In our case, since we are given the present value that we're going to borrow, namely $20,000, and we want to change it into how much will we have to pay in the future, then we're going to be looking for the F over P column. So we can go to the 6% column. It says 6% table. We look under the F over P heading, and we go down the F over P heading until we borrow it for, it says, 1 year. So the interest factor would be found by running across the table where it says 1 till you get 1.06. That makes a lot of sense, because if you borrow some amount of money at the end of 1 year at 6%, they're going to require you to pay 6% more than you borrowed. So you multiply your number times 1.06. Now all the tables work this way, and they're very handy. Sometimes you can't use them directly. For instance, if you have an interest rate with this book of 5%, there is no 5% table. So then you may either have to interpolate these tables or use the basic equations themselves. While I got this reference manual out, I'll just flip back to page 73. You'll notice that if you would like to find F, the future value of something, given its present value, this is on the top of page 73 in the reference manual, then he gives you two ways to get it. You can multiply what you're given times this special symbol, F over P comma I comma N, which is found in the tables, or you can use the basic formula itself to solve for actually this number. In this case, it says take 1, add the interest rate to it, raise it to the n power, and that would also give you the factor to be multiplied by what you're given to turn it into what you want. So for our case, we are given that we have $20,000 loan, so obviously he wants his $20,000 back. At the end of the year, he also wants 6% more of the $20,000. If I factor the $20,000, it comes out $20,000 onto what he borrowed plus what additional he wants for the privilege of my borrowing.